part 2 of my fractions videos. Hi, my name is JuanTutors. My goal is to get you the highest grade on the ACT so that you can get into the college of your choice and the career you deserve. To do that, you really have to have all your tools set up. You have to be ready for it. So now, what do you think is the difference between a student that gets a perfect grade on the ACT versus a student that gets just kind of close? You might think that the student who gets the perfect grade just knows all the tricks of the trade, and the person who gets below it might just be missing some little thing. The truth is that the difference between the highest scoring kid and the next level down is knowing the definitions. How could that possibly be? Because how can the definitions possibly help you solve problems? Well, the truth is that if you know the definitions, like really know them, then you start to realize that the definition is a tool to solve problems. The other thing that separates the nerds from the plebes is that the nerds take notes. So get a notebook and write this down. Hashtag NerdIsACompliment. So on that note, do you know the definition of rational numbers? Like really, I'll give you a hint. There are 2 definitions and they're equivalent. Here's a clip from our most recent video on that question. 2 definitions of rational numbers. 1, a rational number is a number that can be written as a ratio of 2 integers. Another definition, different definition. A rational number is a number that can be written as a terminating or repeating pattern decimal. So if a rational number is a number that can be converted into a ratio of 2 integers or into a terminating or repeating pattern decimal, they have to be the same, right? Well, in this video, I'm going to show that a fraction can be converted into a terminating or repeating pattern decimal. And by the way, both the SAT and the ACT expect you to know both definitions and do expect you to be able to convert between one and the other. So this video is definitely for you. Here's the first example, 63 over 20. 63 over 20 is an improper fraction. I don't want you to get confused into thinking that this is not a fraction. It's definitely a fraction. I see a lot of students say, oh, 63 over 20, the numerator is bigger than the denominator, so it's not a fraction. No, it definitely is a fraction. It is an improper fraction. 63 over 20 is a rational number, and I know that because it's a ratio of 2 integers. We can convert this into a terminating or repeating pattern decimal by recognizing that the fraction bar is a division. So 63 over 20 is in fact 63 divided by 20. So we do this by the long division algorithm, 63 divided by 20. And why not turn this into a nice review of the long division algorithm? 63 divided by 20, the long division algorithm, DMSB, divide, multiply, subtract, bring down. So first we divide, 63 divided by 20 is 3 with some remainder. Multiply, 3 times 20 is 60. Subtract, 63 minus 60 is 3. And now bring down. We need to put a decimal so that we have something to bring down. We put a 0, bring down the 0, we have 30. Now this is the point at which repetition can occur if it does occur at all. Repetition can't occur before the divisor is smaller than the dividend. 3 is what remains after we divide 63 by 20. We look for some repetition unless the division process ends. Now divide again. 30 divided by 20 is 1 with some remainder. 1 times 20 is 20. That's the multiplication. Subtract, 30 minus 20 is 10. Bring down to 0. That's 100. We haven't gotten any repetition yet. So now 100 divided by 20 is 5. Nice, because 5 times 20 is 100. We subtract 100 minus 100, we get 0. So this division terminates. 63 over 20 is exactly 3.15. I invite you to think about it. What is it that made this example a terminating decimal? If you know what it is, give this video a thumbs up and write it in the comments so I can give you a thumbs up too. Let's do an example of a repeating pattern decimal. Let's do 588 over 11. Again, I know this one is a rational number. An integer over an integer is rational, so this is definitely rational, so I know it can be written as a terminating or repeating pattern decimal. Again, we recognize that the fraction bar is a division, so we perform that division. 588 divided by 11. Let's get another practice with the long division algorithm. 588 divided by 11. 11 goes into 58 5 times, that's division. The m multiply, 5 times 11 is 55. Subtract, 58 minus 55 is 3. Bring down the 8. There can't be any repetition yet. We're not down to the remainder. 38 divided by 11 is 3 with some remainder. Multiply 11 times 3 is 33. Subtract, 38 minus 33 is 5. Bring down the 0. Now this is the point where we can start getting repetition or a terminating decimal. So we have to start looking for repetition now. 50 divided by 11 is 4 with some remainder. Multiply, 4 times 11 is 44. Subtract, 50 minus 44 is 6. Bring down the 0. We just got a 6, the previous one was a 5, there's no repetition yet. So now 60 divided by 11 is 5 with some remainder. 11 times 5 is 55. 60 minus 55 is 5. And that is a repetition. The previous 5 and that 5 repeated, so we know that we have the full pattern. 58 over 11 is exactly 53.45 repeating. The repeating pattern is 4-5. Remember that Nerd is a compliment, and click on one of the next videos in this series and click the subscribe button, and I'll see you in the next video.